All right, let's pull back the curtain on the devices we use every single day. We're going to go behind the screen and really figure out what's going on in there.
You know that feeling, right? You click something, you type, you start a video, and it just happens. It feels instantaneous, almost like it's magic. But what's really going on under the hood to make all of that work? Well, that's what we're here to find out.
The secret, really, is to stop thinking about your computer as just one thing. Instead, picture it as this incredibly specialized team of experts. They're all working together perfectly in sync just to get the job done. And today, we're going to meet the whole crew.
Okay, first up, let's meet the most important player on the team. This is the captain, the shot caller, the brain of the whole operation, the CPU.
So the CPU, or Central Processing Unit, is the absolute heart of everything. You can think of it as the team's captain, because every single command, every calculation, every decision, it all flows right through this one chip. Honestly, nothing happens without the CPU giving the okay.
Now here's where it gets really cool. The team captain actually has its own internal team. You've got the control unit, which is basically the project manager, directing all the traffic. It'll send a math problem over to the ALU. That's the team's resident genius mathematician. And while the ALU is crunching the numbers, the internal cache, like a super efficient assistant, is already lining up the very next instruction. And all of this communication happens through the bus interface unit, which is like the main doorway for all information coming in and going out.
And this little team, they work in this constant, ridiculously fast rhythm. Fetch an instruction, decode what it means, execute the command, and then store the result. And this isn't some slow, careful process. This four-step dance happens billions of times every single second.
Yeah, billions. That speed is called its clock speed, and we measure it in gigahertz. A giga means a billion. So if your computer has a 3 gigahertz processor, it's running through that four-step cycle 3 billion times every single second. It's just mind-boggling. So the CPU is the thinker, but a thinker needs information to think about, right? Well, that brings us to the next part of our team, the filing system. In other words, computer memory. Now, there are two main kinds of memory, and the best way to get your head around them is with a simple office analogy. Think of RAM as your work desk. It holds everything you're actively working on right now. Your open documents, your browser tabs. It's super fast and easy to get to. But when you turn off the power, the desk gets completely cleared off. The hard drive, on the other hand, is like your giant filing cabinet. It holds everything for the long haul, your operating system, your photos, all your files. It's a bit slower to get stuff out of, but it's all still there when you come back tomorrow. So, if RAM is the desk, what's cache? Well, cache is like that small stack of essential papers you keep right on the very edge of your desk, the stuff you need to grab instantly. It's even faster than RAM, and it holds the data the CPU uses most often, saving it a trip to the main desk.
All right, so we have a team, and we have a filing system, but how do they all talk to each other? Well, they use the most basic, but also the most powerful language in the world, binary.
This entire language is built from just 2 letters, if you will, a 0 or a 1. Each one of those is called a bit. And when you group 8 of these bits together, you get what's called a byte. And here is the absolute key to it all. A single byte, just a specific pattern of 8 zeros and ones, is all a computer needs to represent one character. That could be the letter A, or maybe the number 7.
Now let's just scale that up for a second. We talked about giga, meaning a billion, with clock speed. Well, here we're talking about storage. A single gigabyte can hold 1 billion bytes. That's a billion characters, enough space for the text of like 4,000 books.
And things like ASCII and Unicode are basically the official dictionaries. They're the translation guides that turn those bytes into all the letters, numbers, and symbols that we actually see on our screens. From English letters to emojis to characters in every language you can imagine.
Okay, now that we know the language they're speaking, let's look at the physical space where this team actually works and communicates. This is the office building and the highway system that connects them all.
So, the motherboard, you can think of it as the office building itself. It's the main circuit board that everything, and I mean everything, is physically plugged into. The CPU, the RAM, the storage drives, they all have a dedicated spot on the motherboard. It's really the foundation that connects the entire team.
And if the motherboard is the building, then the system bus is the network of super-fast freeways running all through it.
This is the electronic path that carries all that data between the CPU, the memory, and everything else. And it's pretty simple. The wider that freeway is, the more data can travel at the same time, and the faster the whole system feels to you.
So we have our local team, right? They're working hard inside their office. But what happens when they need to collaborate with the rest of the world? Well, that's where they connect to a massive, shared online office space.
And of course, we call this cloud computing. At its core, it's really just a global network of really powerful computers, or servers, that our little local team can tap into over the internet. And this gives them access to almost unlimited storage, incredibly powerful software, and just vast databases.
So why is this such a game changer? Well, it's like giving our little office team access to an infinite warehouse and an army of on-demand helpers. Suddenly, they can get to their files from literally anywhere. It saves a ton of space on their local hard drive, and they can instantly scale up their computing power whenever a big project comes along. And this whole model is just exploding everywhere. The Internet of Things is this idea that it's not just our computers anymore. There are now billions of these tiny specialized little computer teams inside everyday objects. Our watches, our thermostats, our cars, all of them connected to the internet, and all of them gathering and sharing data.
So, that team we met today, the one inside your computer, it's now being replicated in billions of devices all around us. Which kind of leaves us with one last big question to think about. As all of these countless tiny teams start communicating and collaborating with each other across the entire globe, how is that going to fundamentally reshape the world we live in?